Topics in Math 2.4 Other Methods of Apportionment. Go ahead and work on this warm-up problem, pause the video, and then you can check to see if you got it right. Okay, so doing the Hamilton method, after we found the quota, we got our initial to only add up to be 20 votes. So we were 2 votes or 2 seats short of what we wanted, okay? So then we had to figure out who gets the extra seats. So we wanted to look at who has the highest decimal place. Since there's not just 1 extra seat, there's 2 extra seats, the top 2 decimal places get it. So the junior class gets 1 extra vote and the senior class gets 1 extra vote. So the adjusted apportionment, Hamilton sophomores get 7, juniors get 7, and seniors get 8. For the Jefferson method, we start with the initial value the same way. So 7 votes for, using that quota, 7 votes for the sophomores, 6 votes for the juniors, and 7 votes for the seniors. From there, we look at what if we would give each of these classes an extra vote? So what if we took that sophomore population and divided it by, instead of 7, by 8? Okay. What if the junior class got, instead of 6 votes, they got 7 votes? So we divided by 7, and the senior 8. And who was the closest to the ideal ratio? Again, since we have 2 votes to pass out, we get to pick 2 winners. So one winner was that junior class. Their decimal was the highest, closest to the ideal ratio. I guess their whole number was closest to the ideal ratio, so they get an extra seat, and then the senior class also does. So it came out using the Jefferson method or the Hamilton method, we got the same answer. All right, let's try 2 new methods today. We're going to try the Webster method and the Hill method. The Webster method uses the arithmetic mean. This is the number halfway between 2 numbers. So if our number was 7.39 as the first one is, it falls between the numbers 7 and 8. So we're going to just add 7 plus 8 and divide by 2. So it's just going to be halfway between that number. So if that quota is above the halfway point, we're going to round it up. If it's below the halfway point, we're going to keep it at the same number, round it down. So this time, we're going to use the same example in the warm-up, okay? But we're going to try using that Webster method. All right, so I'm going to go ahead and get my population and my quota written down. So go ahead and do that. Okay, so these numbers are just the same from the first example. So the arithmetic mean. So since our number is 7 there, we are going to take 7 plus 8, just like in that example, divide by 2. So the arithmetic mean would be 7.5. For the junior class, it's between 6 and 7. So you're going to take 6 plus 7 divided by 2, 6.5. So we're checking if that quota is above the halfway point or below the halfway point. Okay, and notice this is still to get our initial amount, initial apportionment. We still might not get the exact right answer. We might have to add an extra vote or possibly take a vote away. All right, so what we want to do is compare the quota with the arithmetic mean. If it is less than the arithmetic mean, that number of seats stays the same. If the quota is greater than the arithmetic mean, the seats bump up to not 8, but 7, because it was at 6 seats. Now it's going to bump up to 7 seats. 7.7 is again greater than the arithmetic mean, so that's going to bump up to 8 seats. So then you need to add up your seats. So we have 7 and 7 and 8, 22 seats, and that's what I wanted. So then we're done. Okay, so since it matches what we wanted, we are done. Okay, it's good to go. All right, let's take a look at the Hill method. The Hill method, instead of using the arithmetic mean, uses the geometric mean. This is the square root of the product of 2 numbers. So if the quota is 7.39, like the first one, it's going to be between 7 and 8. But instead of adding them and dividing by 2, we're doing the geometric mean. So we're taking the square root of 7 times 8, okay? And then kind of compare it the same way. All right, so go ahead and get your population and your quota on there, and then we'll work on calculating the geometric mean together. Okay, so as it said in the directions, the geometric mean is going to be the square root of the two numbers that surround your quota. So since our quota was 7.39, we're going to do the square root of 7 times 8, which ends up being 7.48. Okay, since the junior class fell between 6 and 7, we're going to do the square root of 6 times 7, which was 6.48. And then the senior class was between 7 and 8. Should be the same answer as the first one, square root of 7 times 8, which is 7.48. Okay, so again, we're going to compare our quota to now, instead of the arithmetic mean, the geometric mean. And this is still getting us that initial amount. It's not getting us our final result necessarily. All right, so first one, the sophomore class, the quota is below the geometric mean, so it's going to stay at 7 seats. The junior class is above the geometric mean, so it's going to bump up to 7 seats. And the senior class is above the geometric mean, so that'll bump up to 8 seats. So again, we're good to go because it added up to what we wanted. We wanted 22 seats, if you look in the directions there. So then we're good to go, okay, since we have 22 seats. All right, let's try the next example. So we're going to do the same thing. We're going to do the Webster and the Hill method. First doing the Webster method and then doing the Hill method. What I want you to do is pause the video and calculate the total population, ideal ratio, jot down the population, find each of the quotas, and find the arithmetic mean. Feel free to go further while you have it on pause if you want. Okay, so we should have been able to figure out the total population was 1,500. The ideal ratio was 50. So if I use that ideal ratio to get my quota, we're going to take the population per class, 422, divided by 50. That's how I get my quota, 8.44. 418 divided by 50, 8.36. 360 divided by 50 was 7.2. And 300 divided by 50 was 6. Next, we're going to compare this to the arithmetic mean. Are these numbers above the halfway point? 8.5, 8.5, 7.5, and 6.5. So which ones went above the halfway point? The freshman class didn't. The sophomore class didn't. Junior class is below, and senior class is also below. So we're not going to hand out any extra votes right away, any extra seats. They're all just going to stay at the whole number that was with the number. Now we need to focus on figuring out the adjusted ratio. So this is a new step that we didn't need to do on the front. So the adjusted ratio is going to be kind of similar to how we figured out the Jefferson ratio. We're going to take that population and divide it by the arithmetic mean. So whatever you got for the arithmetic mean, that's what you're going to divide by. So go ahead and pause it, calculate those, and see who gets that extra. I guess I forgot to add those up here. So we're at 29 votes. We need one more vote or one more seat handed out. Who gets that extra seat? Okay, so if we get the Webster adjusted ratio, we want to look at which one is the highest because there's only one seat left over. So if we look at the whole numbers, 49 is the highest, 0.65. That one is the closest, I should say, the closest to the ideal ratio. So not necessarily the biggest decimal point, the one that is closest to the ideal ratio, which in our case was 50. Okay, so the freshman is going to be the group that gets the extra vote. So the final votes would be 9 for the freshman class, 8 for the sophomore class, 7 for the junior class, and 6 for the senior class, for a total of 30 votes. All right, let's do the same example with the Hill method. So go ahead and jot down your population, your quota, and then we'll work on calculating the geometric mean. All right, so geometric mean, quota, since we got 8.44, we need to take the square root of 8 times 9, which is 8.48. Okay, 8.36 is also between 8 and 9, so that's going to have the same geometric mean that we're comparing. Junior class is between 7 and 8, so square root of 7 times square root of 8, 7.48. Square root of 7 times 8, I said that wrong. There we go. And then the senior class is going to be square root of 6 times 7, 6.48. So then go ahead and compare each of those to the quota. Again, the quota needs to be greater than those in order to add an initial apportionment seat to each grade. So 8.44 was less, so 8.36 was less, 7.2 is less, 6 is less. So nobody gets an extra vote or an extra seat. So we're going to keep them at those whole numbers. But now for the Hill adjusted ratio. Again, it's kind of like that Thomas Jefferson method. It's kind of like the Webster method we just did. But we're going to take our population and divide it by that geometric mean. Okay, so if I take 422 divided by 8.48, which was the square root of 72, we get 49.39 approximately. Okay, if I divide the population by the geometric mean for the sophomore class, I get 49.26. For the junior class, I get 48.11. And for the senior class, I get 46.29. So we need to see which one is closest to that 50, that ideal ratio. And it's again going to be that freshman class. So the Hill final apportionment would be 9, 8, 7, 6, which now adds up to the 30 votes that we wanted. Okay? All right, so your assignment, it is textbook assignment, but it is given on Canvas, kind of like yesterday as a quiz. Okay, so some of the questions are done for you. I started to write the sentence, or I wrote the question sentence and then gave you the answer. So some are done, but do read through those. All right, take care.